Hi, my name is Dylan McGee. I'm a senior at Syracuse University with a major in sport analytics and a minor in information management technology. And for my senior thesis, I did my project on reclassifying relief pitchers using k-means clustering. One of the main reasons why I decided to do this study was because before I transferred to Syracuse University, I played baseball at Onondaga Community College here in Syracuse. My role my freshman year was a reliever, and I was known as the setup man. Essentially, my role was to come into the eighth inning, get three quick outs, and set up our closer in close games. However, I knew what I was good at and my strengths in the game, and knew I was good at getting ground balls. So I never understood why I always had to come in the eighth inning when I could come into situations where our defense needed ground balls to get ground outs. Because of that, I came up with my idea for my senior thesis. Essentially, relievers in baseball have been under the same roles since the game was created. And there's really no reason or meaning as to why these roles came to place. So I believe using a statistical method called k-means clustering, I could cluster relievers based off their strengths and weaknesses using AI, and ultimately come up with new roles for relievers. So instead of their old roles of coming in, let's say in the ninth inning, or when they're down by a lot and they need a few innings as a long reliever, instead their new roles are used for their strengths when needed in the game. How did I do it? I got my data from Fangraphs, one of the most popular websites to get baseball data. And essentially, I used data from the post-steroid era onwards, which is 2005 to current day. I exported the data from Fangraphs, cleaned it, and normalized and standardized it so each variable held the same amount of weight during clustering. If I didn't do this, one of the variables, which is fastball velocity, would weigh heavily in the results. This is because the average fastball velocity in MLB is low to mid 90s, where every other metric I used was a percentage between 0 and 1. So if we were to cluster that way without normalizing the data, it would have weighed heavily on fastball velocity. The variables I used were strikeout percentage, walk percentage, ground ball percentage, left on base percentage, outside of the zone swing percentage, zone percentage, fastball percentage, and fastball velocity. I ran a correlation matrix to see if any of the variables correlated with one another. The goal is for them not to. Ultimately, this came to be a success, and I was able to continue with my analysis. Next, I created an elbow plot to determine the amount of clusters I needed for my analysis. This technique essentially performs cluster analysis from a range of clusters, so from 1 cluster to 20, and will calculate the sum of square errors for each one. You don't want, essentially where on the graph where it looks like the elbow dips is usually the ideal number of clusters. But after numerous test runs, it was determined that 7 clusters was the ideal length for the most accurate analysis. From here on out, I was able to perform the k-means cluster analysis, and the results were pretty interesting. The k-means clustering successfully separated all relievers into 7 different groups based on patterns of their performance and different pitching tendencies. For example, group 6, as we can see in the graph on the results, is the major leader in strikeout percentage, where group 2 is the major leader in ground ball percentage. With this data, we can make conclusions and come up with new roles for these groups. But before doing that, I wanted to make sure there were no extreme outliers in the data. So I created a 3D and 2D graph and colored each player by their cluster to see if there were big outliers. Of course, there are a few, but overall, I do believe the results are pretty accurate. The results came in, and the 7 clusters were as followed. The high velocity specialists, which you would use when looking for strikeouts or a big velocity change. The ground ball specialists, who specialize in getting ground balls. Accuracy specialists, the ones who limit walks. Chase artists, the pitchers who tend to throw off speed that out of the zone to get people to chase. The average reliever, which is self-explanatory. the strikeout specialist, who's known to get strikeouts at all costs, and the least reliable group, who you'd only use if you're trying to save arms or if up or down by a little bit. With this data, teams can use this and look at their own relievers and give them their own classifications. And with that, they can use their relievers in these new specified roles than what they previously were. I do firmly believe that if this was used in Major League Baseball, this would make a difference in bullpens and help teams be more successful on the defensive side of the field. Thank you.